Dear students, today we will solve this problem. The problem is diagonalize the matrix A which contains 161, 120, 003 and hence find A power 4. First, what is diagonalize? Diagonalize means P inverse A P which is equal to D. Here P is the model matrix which contains group of eigenvectors set of all eigenvectors, and here A is given matrix and D is diagonal matrix containing eigenvalues in the diagonal matrix. Diagonalization means P inverse AP which is equals to D. This is the diagonalization. First, to find P, what is P here? Model matrix group which contains group of eigenvectors. Therefore, first we have to find the eigenvalues and corresponding eigenvalues. We have to find the eigenvectors and then we have to find the diagonal matrix. Okay. First we have to find the eigenvalues for this matrix. For finding eigenvalues, we need characteristic equation. By use of characteristic equation, we find the eigenvalues. Characteristic equation is A minus lambda into I which is equals to 0. By applying this characteristic equation to this matrix, we get 1 minus lambda 6 1 and 1 2 minus lambda 0 and 0 0 3 minus lambda which is equals to 0. Keep on after simplifying this determinant, we get the eigenvalues as lambda equals 3 4 and minus 1. 3 4 and minus 1 are the eigenvalues for this matrix. Then for this eigenvalues, next we have to find the eigenvector corresponding to these eigenvalues. To find eigenvectors, we use characteristic polynomial, that is the matrix A minus lambda I into X, the matrix X which is equals to 0. This is the characteristic polynomial. This is used to find the eigenvectors corresponding to eigenvalues. Okay. Therefore, which implies the eigenvectors by this characteristic polynomial apply to this matrix, we get 1 minus lambda 6 1 1 2 minus lambda 0 0 0 3 minus lambda, and here X is the column matrix containing 3 unknowns x1, x2 and x3. Small x1, x2 and x3 which is equals to 0 means 0 vector of order 3, 0 column vector of order 3. This is equation 1. Substitute lambda value first 3, we get, for substituting lambda value as 3 in the equation number 1, we get the eigenvector, we get the eigenvector which is called as x1 is eigenvector is 1 1 minus 4, 1 1 minus 4 is the eigenvector corresponding to this eigenvalue. And for lambda equals to 4, for lambda equals to 4, eigenvalue is 3, 4, minus 1. For lambda value 4, we get the eigenvector x2 is 2 1 0. Then for the lambda value minus 1, we get the eigenvector is minus 3 1 0. For lambda equals minus 1, we get x3 minus 3 1 0 is the third eigenvector corresponding to third eigenvalue. After finding the eigenvector corresponding to eigenvalue, we construct a model matrix P. Model matrix P, which is a set of all eigenvectors. Okay, here P is 1 1 minus 4, 1 1 minus 4 as it is. And in the second column, we write second eigenvector 2 1 0. And in the third column, we write third eigenvector minus 3 1 0. This is the model matrix which contains group of all eigenvectors. Then we have to find the P inverse matrix. P inverse matrix. We already learned about how to, in the previous classes, how to find the inverse of matrix, which is the inverse matrix is adjoint matrix of P and determinant of P. Adjoint matrix for P is found by using cofactor matrix P, the transpose of cofactor matrix, and the determinant P. Here, the determinant P is, the determinant value for P is 1 into 1 into 0, 1 into 1 into 0 minus 0 into 1 is 0, 1 into 0 minus 0, minus 2 into 1 into 0 minus 4 into 1, 0 minus into minus plus 4, minus 3 into 1 into 0 0 minus of minus 1, minus 4 into 1 is minus 4, minus of minus 4 is plus 4, 0 plus 4. So the determinant value is 0 here. Minus 2 into 4 minus 8, minus 3 into 4 minus 12. Therefore the determinant of P is minus 20. And the adjoint P is, which is obtained by using the cofactor, for finding the cofactor matrix and transpose of cofactor matrix, we get the adjoint matrix P, which is adjoint of P is 0 0 5 minus 4 minus 12 minus 4 and 4 minus 8 minus 1. This is the adjoint P. Next, we write by using adjoint P and determinant of P. We write P inverse matrix. What is P inverse matrix? P inverse is 1 by determinant A is minus 20, determinant T is minus 20, 1 by minus 20 into adjoint of P 0, 0, 5 and minus 4, minus 12, minus 4, 4 minus 8, minus 1. Therefore, this is the P inverse matrix. Then, by using eigenvalues, we write diagonal matrix. Diagonal matrix is, which is a diagonal matrix which contains only diagonal elements. The elements are the eigenvalues 3, 3, 0, 0, 4, 0, 4, 0, 0, 0, minus 1. This is the diagonal matrix. Then we check whether P inverse AP is D, which is equals to D or not. Therefore, P inverse AP, which is equals to, consider P inverse AP. What is P inverse? Minus 1 by 20 into 0, 0, 5, minus 4, minus 12, minus 4, 4 minus 8, minus 1. And what is A? A is a given matrix which is in the question 1, 6, 1, 1, 2, 0 and 0, 0, 3. And the matrix P is here. P matrix is here. 1, 2, minus 3, 1, 1, 1, minus 4, 0, 0. This is the matrix, P matrix. First, we multiply these two matrices. Then, with resultant of these two matrices, we multiply this matrix. Then we get minus 1 by 20, minus 60, 0, 0, 0, 0, minus 80, 0, 0, 0, minus plus 20. After multiplying these three matrices, we get minus 60, 0, 0, 0, minus 80, 0, 0, 0, 20. Therefore, 20 gets in outside, inside, divided by 20, we get here plus 4, plus 3, which is equals to minus 1 by 20 into 60 is 3, 0, 0, and minus 1 by 20, 0 is 0, into minus 80 is 0, 4, 0, and minus 1 by 20 into 20 plus 20 is 0, 0, minus. So this is the matrix which is equals to diagonal matrix, which is equals to diagonal matrix. Therefore, P inverse AP, which is equals to D, is verified. P inverse AP, which is equals to D, is verified. Next, we have to find, hence find A power 4. Using this, we find A power 4. How to find A power 4? Consider this P inverse AP, which is equals to D, and multiply P inverse on both sides, we get P inverse A P inverse, which is equal to P inverse. In the diagonalization, we have the P inverse is the identity matrix, and also P inverse P, which is equals to the identity matrix. Therefore, this goes identity matrix. This is the identity matrix. Therefore, I into A I is nothing but the matrix A, and P inverse. If we raise A power 4, then the diagonal matrix get raised to the power 4 in the RHS. Then A power 4 is A power 4, which is equals to P d power 4, which implies P d power 4 P inverse, which is equals to, what is P? We already obtained the matrix P. Matrix P is 1 2 minus 3 1 1 1 minus 4 0 0. One, 2, minus 3, 1 1 1 minus 4 0 0. And d power 4 means the elements raised to the power 4. 3 power 4 0 0 0, 4 power 4 0 0 0 minus 1 power 4, and the P inverse matrix is 1 minus 1 by 20 0 0 5 minus 1 by 20 in minus 1 by 20. P inverse matrix is 0 0 5 and minus 4 minus 12 minus 4 4 minus 8 minus 1 4 minus 8 minus 1. Then we multiply these three matrices. After multiplying these three matrices, we get A power 4 is minus 1 by 20 into the matrix minus 2060 and minus 6120 and minus 1640 and minus 1020 and minus 3080 minus 620 and 0 0 minus 1620. After multiplying these three matrices, we get this matrix, and dividing each element by minus 20, we get A power 4. A power 4 is 103 and 306 and 82 and 51, 154, 31, 0, 0, 81. Therefore, A power 4 is this matrix. We are obtained by this diagonalization. Okay, understood?